In this section, we'll be talking about converting fractions into decimals and decimals into fractions. In converting fractions to decimals, we just kind of follow our idea about what the meaning of a fraction is. That is, here we have 3/8. Well, 3/8 we know from experience means 3 divided by 8. And in performing the division, we will be converting this into a decimal. So 3 divided by 8. Now all we need to do is tack on a decimal and a couple of zeros. I'll use 3 here. 8 into 3, oh, I'm getting ahead of myself. I need to pop that decimal into the answer. 8 into 30, let's see, goes 3. 3 times 8. Subtract. Now, 4 from 0 won't go. I'm borrowing from the 3. It becomes a 2. The one that I borrow makes this 10. 10 minus 4, 6. Bring down the next digit. 8 into 60 goes 7. 7 times 8. Subtracting, I get 4. Then bring down the next digit. 8 into 40 goes 5. 5 times 8, 40. Now the division ended up going evenly, so 3/8 is equal to 0.375 or 375 thousandths. We would presumably write it with the 0 to the left of the decimal and write it like this. Now the division goes evenly, as I say, and it's not always the case that that happens. And when it doesn't happen, we just have to decide on a degree of accuracy that we're interested in and carry our division just one digit farther than that degree of accuracy, as we talked about before. Here's another one. Now 2 3/4 we can convert to a decimal form in actually 2 ways. One way is to rewrite this in a fractional form as an improper fraction, you recall. Now, and then just follow the procedure we had here. Let me show you how that works. We would convert to the improper fraction form by saying 4 times 2 is 8, plus 3 is 11. So this is really 11/4, which means 11 divided by 4, or 4 into 11 like this. Tack on a decimal and a couple of zeros, and away we go. Decimal goes straight up into the answer. 4 into 11 goes 2. 2 times 4, 8. Subtracting, we get 3. Bring down the next digit. 4 into 30 goes 7. 7 times 4, 28. Subtract, I get 2. Bring down the next digit. 4 into 20 goes 5. 5 times 4, 20. Goes evenly, so 2 3/4 is equal to 2 75 hundredths. Now I mentioned that there were a couple of ways to deal with this, and the other way is to realize that the whole numbered part of the decimal is going to necessarily be 2. That is, here the whole numbered part of our mixed number is a 2, so it should make some sense that the whole numbered part of the decimal will also be 2. So thinking like that, we might approach the problem this way. We might think, well, let's see, we don't know what the decimal is, but we do know that the whole numbered part of the decimal is 2. So we just begin this way. Now we can identify the digits to the right of the decimal by just converting 3/4, you see, to a decimal form. So 3 divided by 4, that's 4 into 3, and away we go. Now, 4 into 30, let's see, decimal goes straight up. 4 into 30 goes 7. 7 times 4, 28. Subtracting, we get 2. Bring down the next digit. 4 into 25. 5 times 4, 20. So, as expected, it works out the same way. The decimal part is the 0.75, so we just add the 0.75 here to get our result. Here's one that leads to a rather elaborate division problem. It's 11/16. And in some circumstances, when we are converting from a fraction to a decimal form, sometimes the division will begin to repeat itself. Sometimes it will go evenly after many digits. We just don't know what's going to happen. So we kind of have to decide ahead of time what degree of accuracy is requested, and that'll be given on your homework as the instructions for your homework, presumably. Let's say that here that we want to convert 11/16 into a decimal form, and let's just say that we want this to the nearest hundredth. Well, we know that if we want to round to the nearest hundredth, we need to carry the division out to the thousandths place. And we can see that the division is already here, and the decimal went straight up into the answer. And in terms of the digits that I have up here, I don't need this 5 business. I could have stopped the division right here. You see, because if I'm going to round to the nearest hundredth, I only need to look at the thousandths digit. By the way, the division went evenly to 4 decimal places here, and that's why I carried it out this far. But a lot of times we'll want to round before we even arrive at that position. Now, if we were rounding to the nearest hundredth, we would, let's see, look at the 7, it's 5 or bigger, so we would make this digit 1 larger and lop off. So we have 0.69 as the approximate value of 11/16 in terms of a decimal. Now, the most appropriate thing to do here is not write an equal sign, because the value of, well, let me write it this way. The value of this decimal is not exactly the same as the value of that fraction, because we need it to round off, you see, because we round it off. And because they are not exactly the same, it would be somewhat inappropriate to write an equal sign here. Sometimes that's okay. Informally, it's about equal to, so that's okay. But if we're going to take a formal approach, then the most appropriate thing to write is approximately equal to in making this conversion. Now, it turns out that converting decimals to fractions is even easier than converting fractions to decimals. All we have to do is read a decimal properly, and we are saying the fraction that it's equal to. For example, here, if we just read this properly, this is 4/10. Now, write the fraction that was just mentioned. You see, 4/10 is 4/10 written like this. And now all we need to do is reduce the fraction. This becomes 2/5. In a similar way, 7 and 25 hundredths. 7 and 25 hundredths. You see, so we're writing the mixed number corresponding with the decimal just by saying it properly. Now all we have to do is reduce the fraction. And different people will see this differently, but the fast way to reduce the fraction is to say 25 into 25 is 1, 25 into 100 is 4. So this is 7 and 1/4. Another way to do it, and if you don't see, for example, that 25 goes into 100, you might see that 5 goes into both 25 and 100. And we've talked about this before, but I want to make sure we understand that it's not necessary to go all the way to the end of a problem. We can just pick it off a little bit at a time. 5 into 25, you see, we might see that 5 goes into this, 5 goes into this because of those last digits. And so 5 into 25 goes 5, 5 into 100, well, let's see, 5 into 10 goes 2, you see, evenly, so that 5 into 100 goes 20 times. And now we can reduce this. We see that 5 goes into both of these, 5 into 5, 1, 5 into 20 goes 4, so 7 1/4. Here's a strange looking number that doesn't appear to be a fraction and it doesn't appear to be a decimal. It's kind of the combination of the two. But we can interpret it like this. The 4 is in the tenths place as a decimal. Certainly if we look at just this part, we can see that. So really what we have is 4 and 2/3 tenths. Now, if we follow kind of the direction that we had earlier about reinterpreting the decimal in a fraction form, you see, then we can kind of follow our nose through the problem. So we have 4 and 2/3 tenths. It is 4 and 2/3 tenths, kind of like this. So this is 4 and 2/3 divided by 10. 4 and 2/3 divided by 10. And now, let's make this an improper fraction. 3 times 4, 12, and 2, 14. So we have 14 over 3 divided by 10. And remember, this is 10 over 1. And recall that when we were multiplying and dividing with fractions before, that we changed division into multiplication. So this becomes 14/3 times 1/10. And now we multiply straight across. 14 times 1, 14. 3 times 10, 30. And now all we need to do is reduce 14/30. 2 into 14, 7. 2 into 30 goes 15. So 7/15 is our answer. Occasionally we want to create an order relationship between decimal numbers. And remember, we did that before with whole numbers and fractions. With decimals, it's particularly easy, though, because all we need to do is realize that every digit has value, and we just compare the value of digits as we progress from left to right in the problem. For example, here we have a couple of decimal numbers. Now, look at the whole numbered part. On both of them, we have 2 as the whole numbered part. So just for this part of each one of them, they're equal in value at this point. So we just kind of slide over to the tenths position. Well, they both have 4 tenths in them. So again, they're equal up to that point, you see, in the problem. And then we slide over one more position to the hundredths position. We have 3 hundredths here, but we have 4 hundredths here. So 4 hundredths is more than 3 hundredths, and therefore this number is a larger number than that one. This one is smaller than that one. So we say that this number is less than this one. Now, notice that we get to the point in the problem where we're comparing these two digits which are not alike. And it's important to realize that we don't even consider the next digits in the problem. You see, here we have 3 tenths, there we have 4 tenths. We don't care about the thousandths digit in our two numbers at all. Let's take another one. Now here, it's pretty obvious, I think, that if we're progressing from left to right, 6 is a larger number than 5. The whole numbered part here is larger than the whole numbered part here. So this number is greater than that number, and we just pop in greater than and go about the business of the next problem, because we don't want to even look at the digits that lie to the right of the whole number. You see, obviously 9 is bigger than 0. This 9 is bigger than that 0, and this 3 is larger than that 2. All of that's true. But we don't need to consider all of that. We're just considering digits of equal value from left to right when we compare the relative size of decimals. Now here's a situation where we have a fraction and we're comparing it with a decimal. We'd like to put in some order relationship here. Now, there are actually 2 ways to approach this situation. One way is to convert both numbers to decimals, and another way is to convert both numbers to fractions. If we convert to fractions, though, we need to also consider the idea that the fractions need to have common denominators. So a lot of times in situations like this, it's easier to convert to the decimal form. So here, I would think about changing 7/12 into a decimal. And I would do that by coming out to the side and performing the indicated division. Let's do that. So we have, let's see, 12 into 7.000. Now, I can go about the business of comparing as I go along. The comparison is with the decimal over there, 0.58, if you can't see it right at the moment. But this goes straight up into the answer. I have 12 into 70. It goes 5 times. 5 times 2, 10. Carry 1. 5 times 1, 5, and 1, 6. Subtract, I get 10. Bring down the next digit. 12 into 100 goes, I think, 8 times. 8 times 2, 16. Carry 1. 8 times 1, 8, and 1, 9. Subtract, I get 4. Bring down the next digit. Now, at this point, 0.58 is the same as the decimal I have over here. And I can bring down, let's see, I brought down the 0. 12 into 40 goes, I don't really care how many times exactly, because if this digit has any value whatsoever, then 7/12 is going to have more value than 0.58. You see, if this is, well, let's see what it turns out to be. It ends up being 3. 3 times 2, 6. 3 times 1, 3. And I get a remainder of 4. But no matter. And the division continues with 3's repeated here. But the idea is this, that 7/12 converts into 5, 8, 3, and then the 3 continues forever. But I'm comparing that with 0.58 like this. And you see, they're the same at the 5 digit, they're the same at the 8, but we have a 3 here, 3 thousandths here, no thousandths over here. So this number must be larger than that number, has greater value than that number. So 7/12 then is greater than 5,800.